This video will cover section 5.1, which is verifying trigonometric identities. There is a paragraph on the book that it actually talks about solving puzzles and how solving puzzles actually releases certain chemicals that make you feel good, feel accomplished. Are any of you into puzzles in this class? I used to be when I was little. So yes, that's what happens, when you finish a puzzle, especially if it's a big one, right, like a 1,000-piece puzzle, you will feel pretty happy that you finished it. So what happens with identities is that the book actually compares them to puzzles because they are not too easy, but they're not impossible, okay? Just like a puzzle. And guess what? Once you finish solving one, you're going to feel very happy, very accomplished that you were able to solve it. Now, why do we teach them? We teach them for the purpose of solving equations, and also, of course, for calculus. This class is pre-calculus, right? So it's to prepare you for calculus. And so you will see, but as we get to examples, I will show you what will be the difference in calculus looking at one identity or the other one. So identities, we have already covered a few of these ones. Actually, all of the ones that you see here, we have mentioned them and used them somehow. So we have, of course, the reciprocal identities, which are sine and cosecant. They go together. And then, of course, we have cosine. We have cosine and secant. And then we also have tangent goes with cotangent, right? And so those are the reciprocal identities. Then we do have the quotient identity. And so we know that tangent is sine over cosine. And cotangent, since it is the reciprocal, it makes sense that it will be, that we flip them, right? So it will be cosine over sine. So those things you must know. And actually, this is kind of good for your test. This is kind of like a little review of that. We also went over Pythagorean identities, and I remember that we went over this one, and then we derived how to get the other two. To be honest, I do not know this two by memory, but I know how to get to them. Okay. Let's see. We have even odd identities, so we have that all the odd functions will be sine and of course cosecant because they are reciprocals of each other. Also tangent and cotangent are odd functions, meaning that if you substitute the angle with the negative of that angle or the opposite of that angle, you will get the opposite of the original function. When we say the opposite, we mean this negative here. Yes? Okay. Now, we also have, of course, we have our even identities, and so those will be cosine and also secant, because those two are reciprocals of each other. So now I'm going to move the slide so you can copy the definition. And we have here that trigonometric identities, well, to verify an identity, that's what I expect you all to do. Just give me a sec. Sorry. I know. I was just trying to get this. Let me adjust this, guys. Okay, so we show that one side of the identity can be simplified so that it is identical to the other side. And then there's a period. It says each side of the equation is manipulated independently of the other side of the equation. So I will tell you what I mean by that.
On the word other, the R is missing.
Where?
On the very last line.
Okay, so when we talk about identities, we're not, I don't want you to think that an identity is the same as an equation, okay? The difference here is that when you're solving an equation, you know that something is already true. And so you use equations to solve for variables. And you work on both sides. You use both sides at the same time. What I mean by both sides is like you could say 2x is equal to 8, and so you say divide by 2, right? Or in our class, we don't say that. We could say, well, the 2 is multiplying, so we're going to divide by 2. When we talk about identities, you only work on one side at a time. And with identities, you cannot assume that the statement is true. So you're actually going to prove that the statement is true. And that's why we cannot manipulate both sides at the same time. So let's get to the example. Okay, so we have the first one there. Verify the identity. Secant of x times cotangent of x is equal to cosecant. Okay, and so we are going to call them left side and right side. And one of the strategies is that you go from the side that looks more complicated and you make it look like the side that looks less complicated. Okay, so if you have to pick a side, like which is more complicated, which one would you pick? The left side, right? So we're going to start working with the left side because the left side is more complicated, and our goal is that it looks like this, cosecant of x. So the left side, we have secant and we have cotangent. So we're going to use the strategy of changing everything to sines and cosines, all right? That's what we're going to do. So secant, you can look at the first slide. By the reciprocal identity, what is secant equivalent to, Yvette? 1 over cosine x. Very good. And then, Ruby, by the quotient identity, what is cotangent equal to?
1 over 10.
Well, not the reciprocal, but the quotient.
Oh, okay. Sine over cosine.
Cotangent?
Okay.
The one on the right side?
Oh, cosine over sine.
Yes. Cosine over sine. Okay, and remember, we are just trying to prove if it's true, okay? So right here, of course, 1 times cosine is just cosine x, and then here we will have cosine x times sine x, and again, we're still checking, but what is cosine x divided by cosine x? Is it 0?
No.
No. What is it? 1. So we have 1 over sine x. Now, isn't it true that if you look at your reciprocal identities, 1 over sine x is the same as cosecant x? Is that true? Yes? Okay. So once you have the left side equal to the right side, we're done. And that means that the identity is true. And that's what we're doing. We're not only verifying, right? Verify the identity. That's all we need to do. Yes? Okay, can you guys do the next one on your own? I think you can. You could talk to a partner. Or not. Okay. Okay, so we have the answer there. What I did at first, I used the reciprocal identity of cosecant, which is there. Then the quotient identity for tangent is here. And of course, if we multiply that, we get what we see here. And then sine divided by sine is equal to 1. And we have 1 over cosine. And by the reciprocal identity, that is the same as secant of x. Now that the right side and the left side are equal to each other, we could say that the identity is true. Yeah? All right. Now let's move on to the next slide. Okay, so again, we're going to use the same idea. Change everything to sines and cosines, okay? So I'm going to do that one, and then you guys will do the check. So let's start. We have sine here, so it will still be sine of x. Oh, well, first, what side do you guys think we should work with? Make the left look like the right? Yes, because we always want to start with the most complicated one. So we're going to try to make that one look like the right side. So sine of x is already in terms of sine and cosine, but I'm just going to write it as over 1. For tangent, I want to use the quotient identity. But what would that be, Jesus? You can look at your notes.
Cotangent?
For tangent, quotient identity. Not the reciprocal, but the quotient. So it will be like the... So sine of x over?
Sine.
No.
Oh, cosine.
Cosine. Okay. And so we're trying to see if it's true that it will be secant of x. Okay, so now what I'm going to do here is multiply the fraction, so numerator times numerator, so that will be sine square of x. On the bottom, I will have cosine of x. And then I have here cosine x over 1. Now what I want to do is combine the two fractions, but they have different denominators, right? And remember, we're trying to make it look like that. So if you notice, we have cosine x and 1, so our common denominator, it just makes sense that it is cosine x. So the first fraction is already has that denominator, so I don't need to do anything to it. But my second part of the fraction, I have to multiply. If I want this 1 to turn into cosine x, I will have to multiply the bottom by cosine x. But if I multiply the bottom, I also need to multiply the top, correct? Okay, so I do that, and then I will get, what do I get when I multiply cosine x times cosine x? And remember, we're trying to prove that it is equal to secant of x. Now, here we have the same denominator, so it makes sense I write them under one fraction. So we have sine square x plus cosine square x. And of course, we're trying to prove that it is equal to secant of x. And so, do you guys remember what that equals to? The numerator? I told you one day that it was going to be your lifesaver. So this together is 1. So 1 over cosine x. And isn't it true that by the reciprocal identity, this one is equal to secant x? So now we could say that the left and the right side are equal. So the identity is true. Now, why do we care about this thing? Because I know you're already wondering. So if you were taking a calculus class, and there's a little thing called an integral, which calculates the area below the curve or the graph. So if you were in calculus and you were given this problem, which one do you think it will be easier to solve? Top or bottom?
I mean, easier would be
The bottom. The bottom will be easier. It's actually a formula. Okay. So that's why it's helpful to know how to go from something that is not so friendly into something that might be a little easier to manipulate. Okay? All right, so now I want you guys to try to do the checkpoint 2. I'm going to pause the video, and then it's very similar to example 2. I want you guys to try this one on your own, but I'll give you a little hint. You're going to use the same idea of turning everything into sines and cosines. What will be the quotient identity for cotangent, Janine? Mm-hmm. So remember, we are verifying, we're not saying that they're equal, we're just trying to prove that they're equal, that the left side can look exactly like the right side. So after that step, the one that you see on the board, you could work on getting the common denominator. Oh, I did something wrong. Very wrong. So our common denominator was sine, right? That was multiplied by cosine. So that's why you shouldn't look at the other example. So here we get sine squared, right? And then you guys know already what that equals to. If we add them, so we add cosine square x plus sine square x over sine of x. So that will be 1 over sine x, which happens to be cosecant of x. All right, now let's move on. Any questions so far on this too? Okay, so you guys remember every time I told you you need to get used to those fractions? Yes? This is kind of like one of the main reasons. Okay, let's go to the next slide, guys. Now, we're going to use another technique. Actually, here we're going to be using 2 techniques. Okay. So, if you guys notice, I'm going to work with this left side. And here you might be like, you could probably work with either side. I don't really see one being more difficult than the other. Maybe the fact that one has a fraction. So I'm going to choose to work on my left side. So what I'm going to do is split the fraction. So that means 1 over cosine theta. And the other one will be sine theta over cosine theta. Because this one divides both, right? The 1 and the sine of theta. And then actually we're done. What is 1 over cosine? Secant. So secant theta. And what is sine over cosine? Tangent. That's it. We're done. So if you guys could please complete the next one, it will be the same style. In that case, we could also go from the right to the left side by maybe rewriting them, just keep working on the other one and then I'll show you this one when you're done. Do you guys see? So if I had chosen to work on the right side, I could also make the right side look like the left side. Okay, so I'm just going to write my answer here for you to see. So 1 over sine theta plus cosine theta over sine theta. And of course, we want it to look like that. So the first one by the reciprocal identity, that is cosecant theta. And the second fraction by the quotient identity, that is cotangent theta. So that proves that the left and the right side are identical. So the identity is true. So far, they're pretty easy, right? Yes? Okay. Next one. All right. Now this one, it might require a few more steps, but it's not too complicated. So obviously, we'll work with the left, right? Yeah? Do you guys agree? We should work on the left? Okay. So what we want to do here is have the same common denominator, of course, so that we can combine the two fractions. And of course, we want it to look like this, 2 secant x. I personally like doing this a lot. So what do you guys think the denominator is going to be? The product of 1 plus sine x with cosine x. That would be the common denominator. Do you guys remember those times when I told you if you don't know how to add 1/3 plus, I think I always use 1/2 plus 2/3. Then how am I supposed to teach you that? Okay, so that is the common denominator, because you know here, if we were to add 1/2 plus 2/3, the common denominator is 6, right? Right? And so you know that the first fraction needs to be multiplied by 3, and the second fraction needs to be multiplied by 2. So we're going to use the same idea here, okay? So the first fraction, we're going to have to multiply by what, guys? Cosine x. And the second fraction, we're going to multiply by what? By 1 plus sine x. And we have to do both, top and bottom. Okay, so now here, first fraction, we multiply cosine x times cosine x, so that will be cosine square x. Second fraction, we need to keep in mind parentheses there. So in this case, we have 1 times 1, that is 1, and then 1 times sine x, that is sine x, and then sine x times 1, that will be sine x, and then sine x times sine x, so that will be plus sine square of x. So that is like you have two binomials multiplying each other, or one binomial being square. So it makes sense that we get a term with 4. We get 4 terms, and of course you could see that the 2 in the middle are gonna be combined, right? Okay, if you guys get behind, just please let me know before I move to the next step. Are we clear how I got all this stuff here? So I FOILed that. I multiplied 1 plus sine x times 1 plus sine x. That's what I did. Okay, so after combining, I'm going to have cosine square x plus 1. I'm going to write everything under one fraction because we already have the same denominator. So I have a 1, and then here I have 2 times sine of x, right? Because sine x plus sine x is 2 sine x. Like one apple plus another apple, 2 apples. And then, of course, we have plus sine square x. And we're still trying to prove that that is equal to that. So now what I'm going to do is combine the ones that will equal 1. So I'm just going to go ahead and write them together so you can visualize it. Okay, and so we know that this one and this one are equal to a 1, so we will have 1 plus another 1 here, plus 2 times the sine of x. And then 1 plus 1 is 2. And what I can do here is, if you look at these two terms, what do they have in common? The 2. So I can factor out a 2, and I will get 2 times. If I factor out a 2 from here, what do I get? 1. And if I factor out a 2 from here, I will get sine x. We're almost there. We're about to release some endorphins. Okay. Are those the ones that make you hungry? Yes, right? Okay, good. So then we cancel 1 plus sine x, 1 plus sine x, because they equal 1. And we are left with 2 over cosine x. And so 2 over cosine x is the same as 2 times, what is the reciprocal of cosine? Which is what we have to prove. All right. Okay, any question, guys, on the steps? So you guys are starting to get an idea why fractions are so important, right? I hope so. So when you have your own children, you promise me you will teach them fractions by hand, please? I won't be teaching by then. So, all right, let's move on to the next one. Oh, let me see what I want to do. We're almost done. Yeah. Multiply. It's because the last ones are the best. I'm saving the best for last. Okay. Multiply the numerator and denominator. Whatever I don't finish, guys, I'm gonna have to record. Okay. I'm sorry, but like we just can't get any more behind. I don't want to stress you when the sections get more complicated. Yes, Brandon, they will. Chapter 5, I could read your mind. Chapter 5 gets more intense, and then 6 is easier. 6 will be like a break, okay? All right, let's get this one done. So let me see, what do I want? Multiply the numerator and denominator by the same factor to verify an identity. Okay. Let's try to use... So here we can basically multiply by 1 over 1, and we will not change it, right? Correct? As long as we multiply by the same top and bottom. So now the problem here is figuring out what is that 1 that we're going to use. Do you guys remember when you used to divide imaginary numbers? Something like this. Actually, I don't know if you remember. But just in case you forgot or you remember the wrong thing, you're supposed to multiply by the complex Conjugate. Top and bottom. So this is a trick similar to that. Okay, let me see if it works. Sometimes it doesn't work. So let's try 1 minus cosine x. Okay. So if I multiply sine x times that, it will be sine x times 1. Then sine x times negative cosine x. Do you guys see how effortlessly I'm solving this identity? You know how many years it took me to get to this point? Like 10. You will see when you do your homework. It's not like you have to do a lot of practice. They're not gonna come as easy to you as they're coming to me. Okay? Don't be scared. It's okay. It's normal. Congratulations on your big win. So don't be discouraged if you cannot solve them right away. Okay? It's normal. You just need practice. Okay, so then here, if I multiply 1 times 1, that's 1. 1 times cosine x, what would that be? I'm sorry, negative cosine x. That will be negative cosine x. And then cosine x times 1, that will be positive cosine x. And then cosine x times cosine x, well, positive negative, so it will be negative cosine square x. But what you could have told me is that since the signs are opposites, what can we say about the term in the middle? What happens to it? It cancels. Right? So I didn't even have to do all that. I could have just said 1 minus cosine square x. Okay, and you're probably thinking, yeah, that does not look like what we have at all. All right, what could we do? What could we do? Okay, do you guys remember the Pythagorean identity, right? Very famous. Sine square x plus cosine square x is equal to 1. So what will happen if I keep the 1 on the right and then I take this cosine square x to the right side, so it will be minus cosine square x. So what do I have left on the left? Sine square x. So what I'm going to do is substitute all that by sine square x. Are you going to pass?
No, I was going to ask if you have painter's tape.
Oh yeah. Can you get her the painter's tape? So let's substitute that with sine square x. Okay.
Thank you.
We're almost there. Now, what do they have in common? The two terms in the numerator, what do they have in common? What?
Sine x.
Sine x. So we factor that out. And if I factor sine x from here, what do I get?
1 minus cosine x.
Very good. So, and then from here, you will get cosine. Okay. Now, this part right here is nothing but sine x times sine x. So I can cancel those two out, and now we'll be left with 1 minus cosine x over sine x.
Where did sine squared x come from?
Oh, from here. So I used Pythagorean identity, and then I manipulated it so that it looked like what we had here. Sometimes you have to do that. And so, yes, right? That's what we wanted. 1 minus cosine over sine. Yeah. There we go. But like I said, guys, like, don't expect to just look at my math lab and be like, oh yeah, I'm gonna do this and that and that. It's practice, practice, practice. Okay. All right. Let's get that one. So that one, we change everything to sines and cosines again. So tangent will be sine of x over cosine x. And then here, something interesting happens because we'll have to use odd and even functions. So according to that, sine is odd, which means that the sine of negative x is the same as negative sine x. Those are odd functions. So this one right here, I'm going to replace with negative sine x. And of course, negative times negative, that would turn into positive. Okay, now we need to find the common denominator there, which is going to be obviously cosine x times 1. And that means that the first fraction is good, leave it like that. But the second one, it needs to be multiplied top and bottom by cosine x. So that will give me sine x, cosine x. All of this under one fraction. As soon as I finish this one, I'll let you guys go. So now I'm going to write that numerator in under one fraction, so it will be cosine x. And here I have sine x plus sine x cosine x. Everything over 1 plus cosine x over 1. And then here we could apply the sandwich rule, just to rewrite it. So multiply the outers, that will be sine x plus sine x cosine x, everything over cosine x times 1 plus cosine x. And then we're going to do something similar to what we did before, where you factor out, what do they have in common here? These two, they both have sine. So if I factor that one out, factor it from here, I get a 1. Factor it from here, I get cosine x. And of course, those two are the same, so that equal 1. We could say they cancel. So now we just have sine x over cosine x. And we all know what that equals to, right? By the quotient identity, that is? Tangent. Okay, so I know that maybe I was going too fast. I'm going to keep recording this. Please finish the end. Don't pack yet. I'm still talking. The exam will be on Wednesday. Okay, part 1. That includes sections 4.1 through 4.7. And then section 4.8 will be, you will take it on Friday. Okay, with a substitute. Okay? But you're still responsible for finishing watching the video and completing the homework, which will be due on Monday, because that's the only homework you're going to have for the week. Okay? All right, thank you. Yes. Let me copy this. So for the last problem of the section, we're going to be working on both sides, but one side at a time. So once it will be separately. So if you recall from the first slide, we said that we could only work on one side at a time, and that's what I'm going to do. So I'm going to start by working on the left side first. And you notice here we have two fractions, different denominators. So our common denominator is going to be the product of one times the other. So 1 cosine of theta, the first denominator, times the other. 1 minus, not plus, but minus cosine theta. So I'm not going to work this problem on the left side the whole time. There's going to be a point where I'm going to stop, and then I'm going to work on the right side. So just to continue here, the first fraction we need to multiply top and bottom by 1 minus cosine theta. And so that will give me that times 1, so it's just 1 minus cosine theta. Now the second fraction, it needs to be multiplied by 1 plus cosine theta, so we do the same thing for the top and bottom. And so that times 1, it will just be 1 plus cosine theta. Now, since we have the same denominator, we're going to write everything under one fraction. And we will have 1 minus cosine theta plus 1 plus cosine theta. And on this right side, we have 2 plus 2 cotangent squared theta. Okay, now you can see here that cosine theta and negative cosine theta are opposites of each other, so they cancel. And then we have 1 plus 1, so that will be 2. So on the top, we'll have 2. On the bottom, we will have 1 plus cosine theta times 1 minus cosine theta. So I forgot to press the record button. I'm not so sure how far I got on the recording, but here, if you need to pause the video and copy it, so here I canceled out cosine and negative cosine, so 1 plus 1 is 2, and then the next step was to multiply the two factors in the denominator. Now what I'm going to do next is move to the right side, so what I'm going to do is rewrite cotangent in terms of sine and cosine by using the quotient identity. And so for this number, just a number, I'm going to use sine squared of theta sine squared theta over sine squared theta, because that together, it gives me a 1. And so I will just include the number here. So that's the number, 2. And then here, I'm going to have plus 2 times sine squared, not sine squared, but cosine squared, because we're talking about cotangent. So cosine squared theta over sine squared theta. Now I'm going to go ahead and multiply. So 2 times sine squared theta plus 2 times cosine squared theta. They both have the same denominator, so I can just write them under one fraction. And then from here, what I'm going to do, if you notice, this 2 terms in the numerator, they both have the number 2. So I'm going to factor out the 2. And if I do that, I will get sine squared theta plus cosine squared theta. Now, what I'm going to do on the bottom is, well, let's not do that yet. So here, by the Pythagorean identity, we know that this one here is equal to 1. So I can just go ahead and replace that with a 1. Now, for this part of sine squared theta, I'm going to refer to the Pythagorean identity like we did earlier. And that one says that the sine squared theta plus the cosine squared theta is equal to 1. And so if I want to solve for sine squared theta here, that will equal to 1 minus cosine squared theta. And so what I'm trying to do here is I'm going to take sine squared theta and replace that with 1 minus cosine squared theta, so that it looks like the one we have here on the left side. So that will be 1 minus cosine squared theta. And of course, we have that 2 times 1 right here. 2 times 1 is equal to 2. So that will be 2 over 1 minus cosine squared theta. And so that is the last problem for this section, for section 5.1. And the homework will be posted today, and it will be due the following Monday, which will be the February 15th.